In the first part of chapter 2, you looked at what a relation is, what a function is, and then worked with linear functions. And linear functions are just lines, and these are probably functions that you've worked with in the past, where there's an x value, that's your domain, you plug it in, you crunch a number, and you get out a y, which is your range, and you're going to get out some kind of a line. The tilt of the line is your slope, and you can use the slope and a point on the line to find the equation, or if you have the equation, you can kind of work backwards. And those are the ones that people are the most familiar with. And so the later part of the chapter starts to kind of get away from linear functions and look at some other types of functions. And in chapter 3, we'll look at all different types of functions and polynomials. And so usually it's right about now at 2.5 where people kind of start to get a little confused about what's going on. So we're going to start moving around these functions. And when you move around a linear function, what you are doing is moving around this y-intercept over here, that's your b value, and as that goes up and down, this line is going to head up and down. You saw that in 2.3 and 2.4. When you multiply the x value by some coefficient, it's going to change the tilt of this line. And so you've already kind of seen how to transform functions a little bit. Usually what kind of gets confusing is when we start talking about absolute values and quadratics and other types of equations to move around. But really, it's the linears that are a little bit different than everybody else. Everybody else basically follows the same rule. And that rule is if you add something or subtract something on the outside of whatever gives the function that name. So a quadratic, so instead of x squared, I say x squared plus 1. Instead of x squared, I say x squared minus 3. That's going to move it up and down, just like your b value did. To drag it left and right, which you kind of it doesn't look like you're actually doing that in a linear, but you are, what you would do is you would put it inside of the function that gives it its name. So it would be like the quantity x minus 1, that squared. Let's look at a few. I'm going to pull up the Desmos calculator. Desmos calculator is just beautiful. It is so much nicer than the TI. If you go to desmos.com and you click Launch Calculator, you're going to be able to see a bunch of different graphs, really large, and it's pretty intuitive. So let's look at the x squared. So there's my parent function for my quadratic, my parabola. If I want to move this guy up and down, if I add on a number out here, so a is 1, it's going to move it up. So that's x squared plus, say, 4.4 minus, that's going to drag that guy up and down like that. If I plug something in on the inside, which is not making my function very happy right now, that's what's going to move it left and right, like this. So I'm going to put this at 0 so that we can look at the parent function. And then I'm going to put in here y equals x squared. And now if I say plus 5, it's going to drag him up. And so he heads up there. Let me pull this down a little bit so that we can see. If I make this a minus 2, it's going to drag it down like that. So on the outside of the thing that gives it its name, it's going to move it up or down. If I were to plug something on the inside, it is going to move to the opposite of what you would think. So now I got x minus 3, that quantity squared. So this b value in here, if you will, and I'll get rid of this for right now. Just took my original function and dragged it over to the positive 3, the purple over here. If I wanted to move it to the left, then it would be a positive 3, and it actually goes to the negative 3. So inside's going to go left or right, the opposite way you would think, though. Outside's going to go up or down, just the way that it says. How do you change what it looks like as far as the width? That is going to have to do with what you multiply by. And depending on the function, sometimes it makes it bigger and sometimes it makes it smaller. Let's say I multiply this by a 3. That's going to squeeze that together. If I multiply it by a -3, it's going to squeeze it together and flip it upside down. Negative will always flip it upside down. Also, if I plug it inside of here, it will have the same effect, but sometimes the effect is greater and sometimes it's a little bit less. It kind of depends on the function. So you can see that's much more narrow than, say, y equals 3x that squared. And this is the same for absolute value. So if I want to look at my absolute value function, which looks like a v, my calculator, there we go, and I want to move it up to where that v is maybe floating around over here by the 2, then on the outside I need to say +2. If I want to drag it down, then it needs to be -1 or minus whatever number you want to drag it down to. If I want to scooch this guy over a little bit to, let's say, the +4, then inside over here I have to say -4. If I wanted to have him drag over to the -6, then inside here I need to say +6. Now, just like with the quadratic, because this guy is opening up or opening down, if I multiply by a number, the bigger the number, or I should say the bigger the absolute value of the number, the more narrow it's going to get. And if you multiply by a smaller number, like a half, a fifth, something like that, then it's going to get wider. And if you multiply by a negative, it's going to flip it upside down. The one that looks a little bit different would be my square root. He kind of looks like a, remember when you're in kindergarten and you draw birds and it just kind of looked like a really wide M, so it's like half of your bird, right? So it starts here and heads up. Same thing will still exist. If I want to drag it up, so add on to the outside, drag it down, inside or underneath that radical. If you want to move it left and right, you do the same thing. But now, because it's opening to the right, when I multiply by a number, instead of making it narrow, it's actually going to make it bigger, right? Because it drags it up. And if I multiply by a smaller number, it's actually going to make it flatter. So that's why I said when you multiply the whole function by what we call a scalar, it's going to either squish it or stretch it. The squish or the stretch kind of depends on the type of the function that you're working with. But the rules are the same for every single one of them. And I'm sure they are all the way back here in a chart somewhere. I know it's in your textbook as well. No, I guess not. Where it gives you a list, there it is, of all the different ways that you can kind of move it around. It looks very fancy, but all this is really saying is, if you want to move it up or down, add it on to the outside or subtract it off from the outside. This is inside, left and right, the opposite way. Reflection along the x or the y, it kind of depends on where you plug in that negative. Shrinking and stretching, this is all very mathematical. There's a lot of mathematical speak for saying, well, you're going to multiply, and it kind of depends on the type of function that you're working with. So that is really all that there is to that section. For the next section, we're going to kind of merge the idea of a composite and an inverse together. And I'm going to do that in a separate video because that's going to take a little bit more time.